Hello, my name is Untitled Chapter. I'm from the Technical University of Denmark, and together with my colleague Rune Andersen, we have prepared the indoor climate module of the EERAdata decision support tool. And in this brief video, I will try to give a short overview of what the indoor climate module actually does. So there are three steps mainly in the indoor climate module. The first step is to make a simplified prediction of the indoor environment parameters in the building. And those are right now CO2 concentration, temperature, and air humidity. And we predict those using standardized models that take into account both the building and the occupants. Then we use the output of those predictions to estimate what is the effect on pupil performance and pupil and teacher absence when it's schools, and we use exposure response functions to do that. And finally, we use the output of those exposure response functions to estimate the performance of what it is what it means for the feasibility of different refurbishment scenarios. So one example of an exposure response function is seen here. We have for carbon dioxide on the horizontal axis, and we have pupil performance on the vertical axis. The colored fields indicate the different quality categories according to indoor environment standards. So we have the green field, which is the best we can achieve. The yellow field is a little worse, orange, red, and finally gray, which is completely outside the recommended quality categories of the standards. And we count the number of hours or the percent of occupied time that the indoor environment is in a certain quality category, and use that to estimate then what is the performance decrement caused, for instance, by a too high CO2 concentration in the classroom. A similar example, but in this case for pupil presence. So when the CO2 concentration is low and the air quality is high, then we have 100% presence, and then with increasing carbon dioxide concentration, greater risk of being of transmission through the air of different diseases. So the CO2 concentration here is an indicator of how much ventilation is used in the classroom, and then used as a risk to estimate absence due to diseases that are transmitted through the air. So I'm going to show an example now for a school in Copenhagen, and we use mainly the upgrade of ventilation as the refurbishment measure. So we assume that the school is occupied by 1,500 pupils, 100 teachers, and this is necessary to be able to make the economical calculations after we have estimated the indoor environment. Before refurbishment, the school has one-sided manual ventilation by window opening, which means that if the classroom should be ventilated, then the pupils or the teachers manually should open the windows. And then as part of the refurbishment, we install a mechanical ventilation system, which delivers air corresponding to standards recommendations, and then perform also an ambitious renovation of the building envelope. So the calculated indoor climate, in this case the carbon dioxide concentration, is shown in these two figures. To the left we have before refurbishment, and to the right after refurbishment. And we see how it changes. We have CO2 concentration on the horizontal axis and percent of occupied time in the different quality categories. So in the green field to the left, we have a minimum amount of the occupied time, whereas in the gray area, which is outside of category and not a very good indoor air quality, we spend most of the time before refurbishment. Then after we have modified the building, then we spend most of the time in category 1, which will have some effects on the pupils' performance, this illness absence, and also on teachers' illness absence. And when we estimate the economical benefits then of carrying out the upgrade, then we come to this result, that the net present value of upgrading the building corresponds or amounts to 4.46 million euro as calculated over 20 years. And this is due to higher learning performance caused by the better indoor environment, reduced illness absence among pupils and teachers, and then higher learning performance of the pupils due to reduced absence. We also made some changes to the building envelope, which meant that even though we increased the ventilation airflow rate, then we also have a decrease in the energy heating demand of 22%. And in our case here, the estimated cost of the installation of the ventilation system and the refurbishment of the building envelope amounted to 0.66 million euro. So this was an example of how the indoor climate module can be used to estimate then the economical benefits that are involved in operating indoor environment in classrooms.